So I received a question today about when you're filling or emptying a tank, how do you know what the limits are versus the limits of integration versus the distance that a particular cross section has to travel? So I thought I'd kind of look at that in a little bit more detail in an example. So suppose we have a water tank in the shape of an inverted cone where the height is 6 meters and the base radius is 1 meter. So the first thing you want to do in any of these problems, whether we're filling it or emptying it, is draw a picture and put it onto an XY plane. So we have some reference values. So for me, I put the bottom of the tank on the origin. Now let's see if we can set up to find the work done in pumping the water from a full tank up to the level of the top of the tank so it could flow out. Okay, so keep in mind that density is 1,000 kilograms per cubic meter, and gravitational constant is 9.8 meters per second squared. If I give you the weight per unit of volume rather than density and gravity, that means that density and gravity have already been taken into consideration, so you wouldn't need to multiply by them. Okay, so this tank is full of water, is what we're saying, and we want to pump all the water up to this level. So what I'm going to do is I'm going to look at a little cross section of water. Notice that is a disc, right? So to figure this out, what I need to know is what's the work done to lift one little disc to the top of the tank. And the work required to lift one little disc, wherever it has to go, is the force required to lift that little disc times the distance that it has to travel. And remember, force basically is just the weight of that disc. So that's going to be pi times the radius squared times the thickness for the volume of the little disc times density times gravity. I'm just going to go ahead and multiply those together, and then we'll have times the distance. Okay, now how far does this little cross section of water have to go to get to the level of 6 meters? Well, this little cross section just sits at some y units above the bottom of the tank, and it needs to go to y equals 6. So the distance that it has to travel would be this distance right here. What is that? It's a horizontal distance, so it's top minus bottom, or pardon me, it's a vertical distance, so it's top minus bottom would be 6 minus y. Now for this particular tank, not all of our discs are the same size. Their radius differs depending on where you are in the top of the tank. The lower you are in the tank, the smaller the radius. So we need to figure out a way to determine that radius. Now the radius of this little disc is this horizontal distance right here. Well, you can't really see that. Hang on just a second. Okay. So our radius would be this distance. Okay, it's the distance from the center of the tank, which is the y-axis, out to the wall of the tank, which is this slanted line. Now there's a couple ways you can go about figuring that out. That radius is just an x coordinate of a point on that line. So we could either find the equation of the line, or we could use similar triangles. I'm going to use similar triangles. So I just took this one big triangle and brought it out to look at it separately. So this whole height is 6. We called this height y. This is the radius, and this is 1. So using similar triangles, we know that r is to 1 as y is to 6, or r is y over 6. So this would be pi times the radius squared times the thickness. Now that's the work required to lift one little disc. We want to add up the works for all the little discs all the way up the tank. So when we go to find total work, we're adding up from the bottom disc of water to the top disc of water. Bottom disc of water is down here where y equals 0. The top disc is up here at y equals 6. So we'd be going from 0 to 6 since the tank was full. Okay, so we would have pi times y over 6 squared times 9,800 times 6 minus y dy. Now, if we change this problem slightly and said, okay, we want to, let's say the tank is only filled to a depth of 3 meters, okay? And we want to pump it all out to a level 1 meter above the top of the tank. What about our problem is going to change? Well, we still have the work to lift one little disc is pi r squared, because the discs aren't changing, times the thickness, times density and gravity, times the distance. Now, in this particular case, if we are pumping all of our water out to a point that is 1 meter above the top of the tank, what is that level? Well, the tank is 6 meters tall, so 1 extra meter will be a height of 7 meters. So this little disc right here still sits at some y value, and we're going to have to get up to 7. Top minus bottom would be 7 minus y. So that's for one little disc, and our total work would be what we get when we add up all our increments of work. But what will be our limits? Notice in this example, we're only filled to a depth of 3 meters. So the bottom disc is at y equals 0, and the top disc is at y equals 3. So we would add up from 0 to 3. The limits of integration come from the limits on the water in the tank. So it would be the starting limits of water in the tank if you're emptying it, and it would be the ending limits of water in the tank if you're filling it. Okay, so let's try filling it, say from, let's say maybe we're going to fill it from the bottom. So I'm going to redraw it just so we'll have a reference. And we already found that this is x equals y over 6 here. Okay, and that's our radius. So let's say we're going to find the work to fill the tank with water through a hole in the bottom. Okay, so the work required to lift one little disc is pi times the radius squared times the thickness times density and gravity times the distance it has to travel. Now, if they don't tell us we're coming in from, ground level that's 30 feet or 30 meters below or something like that, we would start from the bottom of the tank and go to its final destination, which is some y value. Now, the way I have my tank drawn, my lowest value is at y equals 0, and we're going to some y value. So the distance that it would have to travel would be y minus 0. And if we're filling the tank completely, when we finish our work, we will have gone from y equals 0 to y equals 6. So our total work will be the integral from 0 to 6 pi times y over 6 squared times 9,800 times y dy. please don't hesitate to let me know if you have further questions.